Hello and welcome to the lecture on data models. This week we are going to explore the vector and raster data models and talk about the differences in the models. You'll then see how geographic data is represented in a geographic information system. So in the intro class you were introduced to various representations of geography. You saw that geography was represented as features or points, lines, and polygons, which you are very familiar with, and I'll talk about that more in a moment. You also saw that geography was represented by the use of images or aerial photos, and that's going to be a big focus of this class, aerial photos, and going one step further, satellite imagery. You also were introduced to surfaces when we use digital elevation models to derive contours, slope, aspect, hillshade, and other data sets to do terrain analysis. You were also introduced to locations when you geocoded addresses to get features on a map. The only one that you really didn't do too much with in the intro class was networks, and we're really not going to do too much with that in this class, but when you get to the upper level classes we'll be working more with networks. But all of these ways are ways of representing geography in a GIS. So let's first talk about what a data model is. It's essentially a structure for organizing geospatial data so that you can work with it in a GIS, and it links geography with the database. And you remember in GIS, that's really the power of GIS, is that linkage of geography to a database, because the linkage to that database allows us to then ask our map questions based on information that's in that database, and also create maps based on that information that's in that database. That's how we symbolize our data, based on those attributes in the file. So there are two different types of data models that are used in GIS. There's the vector data model and the raster data model. Vector data are points, lines, and polygons. So they're discrete data, and they're things like shapefiles and geodatabases, which you're used to working with. Coverages are an older data model, but you'll see those every now and again, so I put it there just for that you know that they exist. Raster data is data that's based on cells, so essentially pixels. Think of raster data as images. It's that simple. So raster data represents continuous surfaces, things that change very quickly, like elevation changes or temperature or surfaces, that type of thing. And examples of raster data are, again, aerial photographs, digital elevation models, digital raster graphics, which are a way of representing topographic maps in a GIS. It's kind of an older type of data set that's not used overly much anymore. But one thing that's really important to understand and to know about as we are working through this class and as you progress in your GIS education is the development of the vector data model. And ESRI really was the company that pushed these various data models, and though they are proprietary data models for ESRI products, you're going to find even when you're using open source GIS products or other GIS software that's not an ESRI product, that you're going to be able to integrate these types of data sets into it just because they're so popular. But the first data model was the coverage data model, and this was a little bit more of a complicated data model and really difficult to work with. So in '94, when ESRI introduced ArcView, they changed the data model to the shapefile data model, which simplified things quite a bit. And in the intro class, we worked almost exclusively with shapefiles, and you remember that a shapefile is more than one file, that it has a PRJ file extension, SHP, DBF, and so forth. So it has a number of files related to it. Then in about 2000, ESRI introduced ArcGIS Desktop ArcMap, which you all worked with in the intro class. This semester we are migrating to ArcGIS Pro because that's the newest software. You just happen to be at the lucky time in the software progression. But with this introduction of ArcGIS Desktop came the geodatabase model, which is really like a relational database. And for those of you that are familiar with Access, it's kind of based on that kind of same type of relational database. So this semester, what we're going to be learning about is shapefiles and how to create them and manage them, and geodatabases and how to create them and manage them. The geodatabase is really the going data model, so we're really going to be focusing on this and kind of migrating from the shapefile to the geodatabase, but we're going to talk about strengths and weaknesses in both and why you want to use one or the other and so forth, and how you can just use both of them very easily within the same project. And just to kind of remind you what a shapefile looks like, just to give you a reminder, remember a shapefile, like right here, we're looking at Pennsylvania school districts. All these files comprise the shapefile, and you have to have all of them there in order for it to be able to be added to ArcGIS Pro or ArcMap, and each one of them has a distinct role to play in things. The PRJ is the one that gives its coordinate system, the SHP is the one that gives its geometry, the DBF is the one that gives the attributes. So again, all of these work together in tandem to add data to a map. But what ESRI does when you go to add any of these to the map, it doesn't show you all of those files, it just shows you the SHP. So like in here you can see that you're only seeing one of those file extensions. So it's just a way of simplifying things. Then in opposite of, and let me switch this up. Opposite of vector data is raster data, and this is data that's based on a pixel or cells, and each cell has a value to it. And this again is really useful for things that change over time and space quickly, like surfaces, temperature, precipitation, and so on. So again, each cell has a value that represents some attribute. So let's imagine like this is a 10 meter by 10 meter pixel. You know that on the face of the earth, when you go outside looking at 10 meters by 10 meters, that it's not necessarily the same thing in that pixel. But what happens is that a value is assigned based on one or more several different methods. A lot of times it's used by the attribute is assigned by the one that is the most predominant in that particular 10 by 10 cell. Sometimes they assign it by what value is in the middle of that cell. So there's different ways of doing it, but it's usually by the most dominant value within that particular cell. So this really becomes a question that we're going to be talking about in the upcoming weeks. This is an issue of resolution. The smaller the cell, the more accurate the data will be. However, the smaller the cell, the larger the file size, and sometimes the larger the file size, it makes it unmanageable to work with in a GIS because it just runs so slow. So there's always trade-offs to resolution, and cost, quite frankly, is a huge consideration. So examples of raster data that you're very familiar with are aerial photos. And you can see that I put 3 different types there just to showcase how we can be using aerial photos and how far aerial photos have come just even within the last 15-20 years. When I started GIS, these black and white aerial photos were the best going, and they were terrible, but that's all that was available across the country. Then introduced color aerial photos, which were also spoiled with Google Earth, ArcGIS Desktop, the base maps, and so forth. But this wasn't something that was commonplace really until about 2005. So it took quite a while to get to that point. And then what you're looking at up here in the corner is what's a color infrared aerial photo. And these are taken during leaf-on conditions so that the health of vegetation can be assessed. So anything that's bright red indicates healthy green vegetation. And we're going to be talking about infrared imagery quite a bit this semester, so you'll get the opportunity to work with it more. The other two aerial photos, the color and the black and white, those photos are taken usually during leaf off conditions so that you can see more and the trees aren't blocking different features that you might be seeing. Then there's also satellite imagery, which is essentially very similar to aerial photography, except that it's imagery taken from space. And the resolution of satellite imagery is not as good normally as what you get with aerial photography because it's covering such a large portion of the Earth's surface. And what you're going to find this semester that the power of satellite imagery is that it allows us to see things that we might not otherwise see, just because multispectral imagery can allow us to change the band combinations of the imagery to look at different features, and I'll show you an example in a moment. And then we also have digital elevation models, which are an example of raster data. So just to quickly jump over then to ArcMap, going to the DEM example. This is what a DEM looks like when you first add it to ArcGIS Pro. And if you remember, a DEM is a grayscale image that has an elevation range. For instance, this one is going from 385 feet to about 1336 feet. And we learned in the other classes on how to symbolize this so that it looks a little bit more like elevation. So I'm just going to pop that in here quickly, so that we have something that looks like this. And we learned that with digital elevation models, we can derive hillshade, contours, slope aspect, you name it, lots of different data sets. But if I click on any one cell here, notice that where I clicked was showing me that elevation value is 869 feet. And notice that when I scroll in, and it might be a little hard to see on screen, notice you start seeing the individual cells. And if you want to know the resolution of something like a raster data set, all you have to do is grab your measure tool and measure the size of the pixel, and you can get that value, and you'll have the opportunity to do that in a later exercise this semester. But again, you can see this is raster data because it is data that's based on pixels or cells. Same with satellite imagery. This is a Landsat image of central Pennsylvania, and right now we're looking at this in a natural color band combination of 432. This is Landsat 8 imagery. When we come over here, we can now change the band combinations to be looking and accentuating different features. For instance, if I want to look at color infrared so that we can look at areas where healthy green vegetation exists, we can make that band combination. If you want to be looking at other features, and I'm just going to just change a few bands here just so you see what happens. Notice how with these different band combinations, different features in the imagery are highlighted. This can be useful for a lot of different reasons. This could be useful for finding different features that you may be looking for, like just accidentally here. If you kind of scroll in, you can kind of really see in this band combination that roads and man-made features really pop out, and this is really helpful if you're going to be digitizing or creating any data from this imagery. So this is imagery that we're going to be working with throughout the semester. And then just as another example, while we're here, all the base maps that we use in our GIS Pro and desktop, they're all raster data sets. So then let's go back here to vector. We started talking about that in the beginning, and just to kind of serve as a reminder, vector data are points, lines, and polygons. So here we can see that counties are represented as polygons, roads as lines, and then bridges as points. So this is discrete data. There's specific X, Y associated with all of these features that you're seeing on the map. And if we open up the attribute table, we can see that it has attributes associated with each one of the features. So that's an example of vector data. And going back to the lecture here, let's talk about some ways that we can be using raster data and why it's important to have it. And there's a couple of examples listed here. First is as a base map. And this is something that you're very used to. It's just as a visual backdrop for a map. And this can be really helpful for providing geographic reference, geographic context to other data. So essentially we are it's the bottom layer, and you're putting vector data and other surface data on top of that base map. Now, as one aside on here, a base map does not have to be on every map that you create. A good example of that is a graduated color map. There's absolutely no reason for a base map on a graduated color map. So there are times when you have to decide whether or not it's appropriate. ArcGIS Pro will automatically add a base map. It doesn't mean you have to use it. Another example of when raster data sets are used is by looking at land use and how land use has changed over time. Again, satellite or aerial imagery is used to categorize areas into different land uses, and then a process called classification is done to figure out what land is in what particular use. And you will be doing a classification exercise this semester. We'll be spending a whole week on that topic, and we will be talking about land use quite a bit this semester. Another example of raster analysis is a hydrological analysis, where we use digital elevation models to determine the direction of water flow, where flow can accumulate. We can delineate streams, networks of streams, watersheds, basins, and so on. So it's really useful for that. So this is, in terms of applications, this can help predict where runoff will be, where floods, which areas are at risk of floods, mapping floodplains, and so on. Environmental analysis. The imagery that we're going to be working with a lot this semester is data from the Landsat program. And the Landsat program has been running continuously since 1972. And this has given us global coverage of the Earth with satellite imagery, so for over 40 years. So with that, we can be looking at lots of environmental topics and how things have changed over time, how icebergs have receded, how habitats have changed, and so on. So it's used heavily in that area of environmental analysis. And then terrain analysis, and we did this again in the intro class. Slightly, we learned how to derive data sets, but we really didn't do any like hardcore analysis with the data that we created. This semester, we're going to go a little bit further with terrain analysis, and we're actually going to be using a data set called LiDAR data, which is really high resolution terrain data. You're going to learn how to work with LiDAR data sets and then create different data sets from that and how to do analysis with that. As a really good example of LiDAR data, and one that's been really recent, is if you've watched the news or seen the news in the last year or so, you might remember how LiDAR was used down in the Yucatan Peninsula in Tikal to find a lot of different Mayan ruins that were not known about because LiDAR can help us see kind of through the noise of vegetation, of train and so forth, they were able to use that technology to pick out where these ruins were, and it's been used a lot in historical analysis and archaeological analysis. So we'll be working with LiDAR data quite a bit this semester, and you'll find that Pennsylvania has really good LiDAR data sets to work with, which is really a lot of fun. But other applications other than that are just like, modeling landslides and looking to see where geologic hazards might happen. It's used in urban analysis because you can actually render buildings from that data set. So the applications of LiDAR are insane, and we're going to work with a number of those this semester. So then last, I just want to finish this up with talking about some raster formats that are out there, so that when you see these file extensions, you know what they are, and you don't let them kind of unnerve you. The most common raster file extensions are the ones that I have bolded in red, like the JPEG, which you're all familiar with just because other just non-geospatial data uses JPEG and TIFF. So those aren't going to phase you, which the SIDS can be added directly to ArcGIS. IMG files can be added, and then the native raster format in ArcGIS Pro is what's called a grid data set, and you'll learn how to work with those. I'm not a fan of them because I think they make things a little bit too complicated in terms of data management. So I often will export as an IMG because I think they're nice and simple to use, and they're easy to manage data-wise because you can easily copy and paste them without missing files. Grid data sets are a little bit more complicated than that, and sometimes if you do move things around, you can miss things, and it then blows up your raster that you had, which is frustrating. So I like to simplify, so I go to the IMG. So hopefully this helped give you a little bit of an overview of data models. We're going to continue talking about it in week 2 when we talk about vector data models. We are going to be learning how to create shapefiles and geodatabases and how to manage them.